Today we're going to look at energy in a mass spring system and how it changes and what really affects how much energy gets stored inside that mass spring system. So the first thing we're going to look at is we're going to look at the total energy, and the total energy is based on the kinetic energy and the potential energy. So at any point, if I know the mass, the speed, the spring constant, and where it is, I can figure out the energy. But there's two important points, 2 points where either the kinetic energy is zero or the potential energy is zero I'm going to focus on today. So one of those points is when we reach the maximum displacement, we reach that amplitude point. Because at that amplitude point, the object comes to rest, okay? Meaning the kinetic energy is zero there. Okay? The other point I'm going to talk about is this point where x is equal to zero. And when x is equal to zero, there's a few things that are zero. So let's go ahead and figure out what those are. So if I'm looking at this problem, the sum of the forces acting on my object in the horizontal, assuming this is on a frictionless surface, of course, is equal to ma. I do have the force from the spring is going to be negative kx is equal to ma. So at my point when the position is zero, the acceleration is also equal to zero. Okay. And if position is equal to zero, I can see that my potential energy is also equal to zero. And if that is true, well, that is true at x equals zero, I should say. So let's think about the other points. Okay, so at this point, my position is a maximum. Well, if my position is a maximum, that means my acceleration is a maximum. If my position is a maximum, that means my potential energy is also a maximum. And if I think about this point x equals 0 over here, all right, so you're telling me that a is equal to 0. So dv dt, the derivative of velocity, is equal to 0. That means at that location, the velocity is a maximum. And if my velocity is a maximum, that means my kinetic energy is also a maximum. So these 2 points have some interesting maximums and minimums that occur at these points. So let's go ahead and just figure out what's the total energy at each of these points. So the total energy at this point, kinetic energy plus potential energy, is going to be just equal to the total amount of potential energy. So 1/2 kx squared. And so the x here at this point is a maximum, and we just call it a. So I have 1/2 k a squared. So this is the total energy in a spring system. Now, the question is, what happens if I increase the amplitude? Like double the amplitude? Well, doubling the amplitude, well, it's squared, so it's going to be 2 squared, so 4 times the energy. Or if I double the spring constant, well, it's just to the first power, so it'd be like doubling the energy. So we see that spring constant and we see that amplitude change the energy. Okay, let's look at this other point over here where our energy is equal to k plus u, but at this point our u is 0. So our energy is equal to 1/2 mv max squared. So then you might want to say, well, what if I increase the mass? Does that also increase my energy? Or if I increase the maximum velocity, does that also increase my energy? And what I want to show you here is if I change the mass, Vmax doesn't stay constant. Okay, why is that? So let's think. So if I change the mass, but I still leave the amplitude and the spring constant there where they were, but I only change the mass, that means my acceleration is going to change. If my acceleration changes, that means my maximum velocity also changes. So does it have an effect or does it not have an effect? And so this is what I want to do for us here. So I'm going to go ahead and plug in Vmax as omega times A. All right, so my energy is going to be 1/2 m times omega times A. I'm just going to square both of those. Now this is a spring system, so omega is going to be the square root of k over m. So I'm going to make that substitution as well. So my energy is 1/2 m times omega squared, so k over m a squared. My m's cancel, and so the energy is really, again, only dependent on spring constant and amplitude. You can put any mass on there, and it will have the same amount of energy. Now the difference is the more mass you put on there, it'll just change the period. So it'll just move slower through that middle point. It'll just take longer. It'll have the same amplitude, but it'll just take longer. And that increased mass accounts for the decrease in velocity. But you'll see here, the big idea is the only two things that can change the energy are amplitude and spring constant for a mass spring system. There we go.